Welcome to another teardown video. Yes, let's take another scope. This time it's a LeCroy 9350A, 500 megahertz. So how is it doing 500 megahertz if it's 500 megasamples? Alright, this scope is fully software controlled, so every input is, see, completely software. This scope is defect. There's something with the power supply, so that I am not going to turn this on before open. That is how it is with this one. But I think it could be pretty interesting to see if this one can do anything cool. I'm a little bit confused about this cal, some channel for cal, and of course this is external trick and something, and then just channel 1 and 2. Okay, fine. And with this auto range thing, but then LeCroy probes with 6 extra pins. That is a little bit interesting. I am not super familiar with the LeCroy, so that's gonna be interesting. Anything else here is just the normal stuff, channels, yada yada yada. You just change the different channels and then, alright, you got the channels here. Channels 1, 2, on and off, and trigger, yeah, everything here looks a little bit normal. Let's look at the back before we open. So, pretty standard rear panel. If you look here with my hand, it's really big. Fuse 6, easy to access. Okay, so this is a switch mode multi-voltage power supply, and it looks like we can access some plug-in cards. I wonder if this is proprietary or some motherboard, or maybe there's a PC in there. When I see stuff like this, is this ESA? What kind of stuff is this? And on the top of this scope is something you're gonna love. Disk drive. Look at that sexy angle. You kind of put your disk and just slide it in. That is really sexy. And this one is a printer. So what, you lift this, stick in a roll of paper, and then that is pretty cool. You can print out your curves. Okay, so this is the inside of the lid, and the disk drive, and the printer, and there's a power supply for the printer. And inside the unit I found these 2 cables, and they're different. So it can only be this one that goes for the printer, and as far as I can see, the only way to mount this is that way. Oops, it's too wide. Duh. Okay, so I'm completely drunk. So it gotta be the other one then. Okay. Yep, we got a winner. And then the other one. Ooh, that looks different from that one. So it can't be that one because this doesn't fit. So here's the other end. Alright, so what is the idea? This cable goes either that way or that way. So 50% chance of a blow up. No, this fits. There are no locking pins. Ooh, no coding pins. Then how can I know if there is a kaboom? Okay, but this goes in this side. And let me see if this thing's mounted that way. Cables to the right. Yeah. The printer, where the heck can the... Ah, there's an interface here. Here we go. This is the only way it can reach, and the other one, I guess that's it, right? And thank you so much for all the screws in the little bag. I love it. That is fantastic. The power supply is missing. So I guess there was a blown up power supply here. And it was, yeah, okay. So this is probably the connectors for the power supplies somehow. But, or this is half of the rest of the blown up power supply. But with all the voltages neatly written. So let's just, before we do any more damage to this unit, how about we just power this up and see what happens? Yeah, because this is what we do, right? We power up and then we see what is gonna happen. Ooh, I like to see the rest of the stuff, but look, it was not opened. And there's a big metal shield where you can access everything. Here is really nice. All right, let me see if I can find some power supplies, and we'll see what's gonna happen here. Nice little CRT. Production date 34 year. Look at that, 94. Right. So yeah, this thing is from 94, and I also saw a Cal sticker 99. All right, so we have already dated this thing. I am now ready, I guess. I needed quite a lot of power supplies, also because of the current, the usage that was written here on this connector. So I'm a little bit worried. I think that I hooked everything up. Those two needs to be in parallel. Here is, we got my plus and minus 15. How about we just boot up the plus and minus 15 first? Okay, and then those two. Right, so this is minus 5.2 plus 5 volts. And the 15, yeah, I think everything is running. Obviously it's a CRT, so well, should we see something? I don't hear any clickety clackety going on. Also, I was looking for an on-off switch, but maybe this is just on the back. Nothing. Maybe there's a difference in... Maybe I didn't connect it in the right order. Is there a power sequencing thing? Should we try and turn on and off? Okay, so that was the fan. Did that react to anything? Let's turn off the... Oh, we got filament. Yay, at least that. And no explosions. Where's the display intensity or the... Amen. No locks so far. Maybe I should, I don't know, try and reboot the 2.5 volts. Also, I saw a little bit funny PCB here that is connected to mains. Maybe this is a mains input voltage line input thing. So maybe it's not going to boot up if there is no mains frequency. So that is my next Maybe I should do that now, because that is really... Ooh. Alright. What the heck is that? It looks like it's alive. So what is this? Hey! Channel 1? Channel 2? Well... Of course, I need to figure out how to operate this thing. Ah, okay. So this is... Ooh. 1 nanosecond, huh? Okay. Whatever. It is alive. I needed to add a couple of hundreds of millivolts also on the negative to compensate for the voltage drop on my cables. Because this is quite a lot of amps. Look at that. And those 2 amps you need to add together, so it's like 5 point something, right? A lot of amps. And all these cables, what is it, 1.5 meters or what? So I was losing too much, so it didn't run. I also put the top cover on and connected the disk drive and the printer. Let me take this off and see if it still runs. Oh, I didn't even power on the mains. See, I forgot the mains input. Alright, great. Well, so far I'm actually quite happy about this. See, and all the couplings, and you can go 50 mega or 50 ohms and all that, and mega ohms and whatnot. And it really works in all the different ranges, and it measures the right amplitude and frequency and everything. It also responds quite fast. See? So that is really nice. Let's test the bandwidth. That could be interesting. So I put it into 50 ohms, and I removed my 50 ohms coupling that I normally use for all sorts of older scopes without this feature, but it's really better if you got the 50 ohms coupling inside. So now I'm gonna test, and this is 1 kilohertz, 1 volt peak, and that should be right. Let's crank it up a little bit. Like that. Let's see what happens. I just crashed it, and now it's in 10 gigasamples per second. Ha! That is pretty cool, and this is 100 megahertz input. So I have somehow 500 megasamples, but it can go a lot faster. There's some funny thing that I just enabled. How is this possible? This is at the moment it is only 100 megahertz input, but let's crank up the inputs again. It happened when I gave it. So this is 300 megahertz, 400, 500 megahertz of input, and then yes, exactly. See, 500 megasamples, and then you should get 0. So this is actually correct. And now I don't understand this 10, but it can go really fast now. There is a really weird 1 nanoseconds per division. Is that right? Yes. Really? Alright, let's do this together, okay? This is 1 megahertz. Okay? Look at the amplitude. Okay? So this is 1 megahertz. Now I do 10 megahertz. Alright. So let's go for 50 megahertz. See, there's a little bit of funny alias here, but this is of course 500 megasamples, so there will be some sort of a timing thing. But if I go like this, it is absolutely fine and stable again. So let's go for 100 megahertz. See, the level is now a little bit down. 100 megahertz, right? So let's do 300 megahertz. And now it's looking a little bit funny again. Okay, let's go for the mega 100s, 400 and 500. Alright, so this is 500 megahertz, and look at the nice curve. There's quite a lot of samples here. This is crazy. Okay, I think I figured this out, okay? Of course this is not 10 gigasamples a second, but this is the effective sample rate because it's doing 10 time interleaved samples, and this is actually what it's saying here. So it's going to, see, if I go down here, now it's going in true 500 mega samples per second, and this is 10 nanoseconds per division. And if I input 10 megahertz in this mode, I get a super nice and stable curve. But if I go faster, it enables this time interleaved mode, and then the effective sample rate will be 10 times higher than the true sample rate, because it's just time skewing a little bit and then making a new sample into memory. Still, really impressive what they did with the bandwidth and everything, and also how fast it's reacting, going in and out of all those modes and everything. I think maybe it is time now for Teardown. Let's see what is inside this thing. So, I think I'm more or less half the way into all the good stuff. I figure out to loosen up the screws here in the bottom and then the sides, and then I was actually a little bit surprised to see the entire front came off. So, and this is the screen and the high voltage supply, and this is actually everything that has something to do with screen in one neat unit. And yes, of course, that will be all the buttons input. So yeah, the screen is actually driven and supplied and everything from this tiny little cable. That is it. And here we can see what is driving the screen. That is pretty neat. Okay. VH and sync and -15 and a ground and here plus 15 and -15 and some grounds. Yeah, so that's all you need for the entire screen. And this is the back side of, I guess this will be the CPU or master main controller. Oh, you can take this off. This is just a, okay, just a bracket of some sort for the memory modules. So how do we get in here, and how do we get this out of the casing? So that was a little bit difficult to disassemble. Look at this. There's a little springy connection to the probe gain connection. This one goes up here and is connected to the PCB. And with all those screws removed, and including all those down here, I think I should be able to now... Oh, I need 2 hands. I think we are more or less all the way in. So, this is only a 2-channel scope. And what have we got here? room for 2 more channels on the same main board. And that will, I think, this is the analog front end, right? With all the different ranges and fancy things. And that is AD conversion, right? And look at all that stuff. Then we go through some digital memory chips. And here, a lot of really fast paralleled memory. And with 2 big capacitors on the back to make sure it is running stable. See, we've got more chips on the back. And here, look at this tiny little funny wire on one little pad of this IC. This is just to create a tiny little delay to fix something. That is pretty cool. All boards inside this one contains some sort of modifications, little wires, little funny add-ons all over the place. And this is the external trick, I would guess, and this is the cal. I don't know what that is yet. I am sorry, I did not read the manual. We see a lot of LeCroy written on ICs, but it's really a beautiful PCB layout. What is that? What is inside this? We got a 10 megahertz TCXO. Wow, that is nice. And what are they? Some high precision components. Alright, I will try and pull this up and see if there's more fantastic stuff. The inside of the case is coated with some kind of a spray paint. And it is very well conducting. So that is just great. Good shielding. Also, what I found here on the bottom side of the main PCB, look at the timing delays. And up here you got some more RAM modules of some sort. And look at all the delay lines. And here you can cut and strap and fine-tune the delays. Obviously, when you're running really fast, you need some delay lines. And here we go again. And I think those black ICs, I think those are also delay lines, because it says 2.0 nanoseconds. And we find them quite a lot on the top. And also, if we look in here, I don't know if I can get some light in here, but we see some relays. And for the 2 fast channels, I also saw some coaxial relays and high-speed shielded relays all the way down at the input. Ooh, I have to be careful with this board. So what I mean is, they are, see, the round pads, very close to the input. There is one relay here and there's another one here. Probably for grounding and AC and DC and 50 ohm termination. I've been looking a little bit more of the circuit up here, and I think maybe, I don't know exactly what this part is doing, but it is interfaced with some part that gets really, really hot, and this part is connected via a lot of wires for this memory interface chip. And if you look at the other channels that is not populated, you see, so this is probably analog input, and this is doing some analog gain stages or some broadband variable gaining and handling. And I guess this little thing is actually the AD converter, because then you got a lot of data coming out of it. See, a lot of parallel bits for the memory interface. No, those chips are of course not mounted, but they are on this channel. So yeah, I will try and assemble the main plate again here. So this is the CPU card, and look at that, 68,000. It's an EC030 with a math coprocessor. So this is 16-bit of fantastic things. And I believe this is the DA converter for the display. This is also where the cable is for the display, right? This was the cable for the keyboard. This is for the expansion slot. And we got some RAM. Well, there wasn't a lot of anything on the other side, but it's a beautiful PCB layout. So all we have to do is slide it in here.